Next, what I want to do is I want to look at the span of another set of three vectors, say 1, 2, 3. How about 2, 1, negative 1, oops, and let's say 3, 3, 2. I want to determine by look at, let me be a little bit more precise. I want to describe the span of these three vectors. And so I want to look at the system, and I want to know, is the span all of our three or not? Okay, that's really the big question. And so let's pick an arbitrary vector. Pick, let's say, S, T, and R, arbitrary, in R3. And let's do it. Let's try and write these as a linear combination. So we want to find, values A, B, and C. So that A times the first vector plus B times the second vector plus C times the third vector is equal to S, T, and R. Okay, and so let's think about this. We gotta multiply each of the vectors by A, B, and C, add them up, and then equate them to S, T, and R. So this ends up giving us the equations. We have the system 2A plus 2B plus 3C equals S. 2A plus B plus 3C equals T. What else? 3A minus B plus 2C equals R. Okay, and there's a few different ways that we can go ahead and solve the system or try to. One thing that we can see right away is, let's look at the determinant of the matrix. So 2, 2, 3, 2, 1, 3, and 3, negative 1, 2. Again, remember that these values of the matrix are really just the vectors. So the columns are 2, 2, 3. Where did I get 2, 2, 3 from? Confusing myself here. This should be 1, 2, 3, sorry. So 1, 2, 3, so A plus 2B. Yeah, because the vectors here, 1, 2, 3, so I need to fix this one too. So the vectors are 1, 2, 3, 2, 1, negative 1, and 3, 3, 2. Okay. So if we take this determinant, it turns out that what's going to happen is the determinant is going to be 0. And the way that I know that the determinant's going to be 0 is that the last row, the last column, is the sum of the two preceding columns. So so this determinant's going to be 0. You can do it by hand if you want, but I know that that column is the sum of these two columns, so the determinant's going to be 0. If you want to formally think about why that should matter, take the transpose, and then the columns become the rows, and then when you do row reduction, you'll end up with a row of zeros. Okay, and then once you have a row of zeros, you know the determinant has to be 0 because you can just expand along that row. Okay, so the determinant's going to be 0, and that's again because the last column, 3, 3, 2, can be written as a linear combination. In this case, it's just the sum of 1, 2, 3, and 2, 1, negative 1. Okay, and so it turns out that if you were to try and solve this system, you would not get all of R3, you would only get a certain subset. And it turns out that the subset that you would get, so the span of the vectors 1, 2, 3, 2, 1, negative 1, and 3, 3, 2, is not going to be all of R3. It's not going to be three-dimensional space. It'll be just a plane through the origin. And you can do the algebra and figure out what exactly is that plane, what's the equation for it, if you really feel like it. But this is going to geometrically be a plane through the origin. So it turns out that these three vectors do not span all of our three.